A function is a rule that will for every number give you precisely one other number. So if you have a number x, you have a rule that will give you another number y in a determined way. And this is the number you plug into the rule, and this is the number you get out. So this is input output. You can also write it as that y, the output, is a function, writing f as a function. It's a function of what you plug in, x. So this is a symbol for y. So this is just another way of writing y. Okay, so let's take some examples of function. For example, f of x equal to 2x plus 1. This means that if you plug in the number x, the number f of x, that is also y, you will get out is equal to 2 times that number plus 1. So for example, if you plug in 1, you will get out 2 times 1 plus 1. And this is 2 plus 1, 3. Or if you plug in 0, 2 times 0 plus 1, that is 1. So you can plug in any number you like here. Another example is if you take the function x squared. Then if you plug in, for example, 0, if x is 0, then y is equal to 0 squared, and that's 0. Or if you plug in 1, then you get out 1. In the examples we saw, we just put in some numbers for x and saw that what we got out y. All the set of all possible x that we can plug in, because sometimes you can plug in any number, but sometimes you're limited to some set of numbers. So the set of numbers you are allowed to put in, that we call the domain. So that's all the numbers that this function is defined for. So you're only allowed to put in numbers from that domain. And the numbers you get out belongs to another domain that we call the codomain. So let us look at the function f of x squared again. So here the domain could be, for example, all real numbers, and you can write all real numbers as a big R. So you're allowed to put in any number. And let's say that the codomain also, you get a number as a real number. So if you plug in real numbers, you get out real numbers. So this domain is the real numbers and also the codomain. But if you plug in numbers now into this function, you will always get numbers that are either 0 or positive. You will never get out numbers that are negative. So you say that if you plug in all the numbers here from the real numbers, what you will get out is a set of numbers, a set of all the numbers you get out. That will only be positive numbers or 0. So what you talk about the range of the function. So they are possible. The codomain says that they will end up in this, but in reality they will end up in a smaller part of this, and they call it range. So they will end up in a set of all y's equal to or larger than 0. So this is the range or the image of the function. So if you plug in all real numbers here, what you will get out is a set of numbers, set of y's, and those set of y's will be all y's larger than or equal to 0. So this is called a range. So this is just what potentially they could end up in, and this is in reality they will end up in. So we have a function y equal to f of x. You say that y is a function of x because y depends on x. So x is sometimes called the independent variable. Because you can choose x freely, at least freely from the domain. But y, that you call the dependent variable. Because once you have chosen x, then y is fully determined. So y is dependent on what you choose for x. So you can choose x freely, so it's independent, but y is dependent on x. So you call it a dependent variable. You can think of a function as a machine. So if we have an apparatus or a machine, we call the machine or apparatus f. Then the function is x is what you plug into the machine or the apparatus. And then y is what the machine will give you out. And will give out you different things depending on what you put in. For example, a real world example could be a coffee machine, where you can choose what type of coffee you want to have. And then x will be the button you pressed on the coffee machine, and y will be the type of coffee you will get out. So for example, if you put in or you press button number 1, then y could be ordinary coffee, or you can say black coffee. And if you press the button number 2, you will get out the latte, for example, and so on. So this is a concrete example of what a function is. So a function is not a number. Function is an apparatus, a rule for giving you one thing when you put in another. Functions are much used in science. For example, in physics, they are abundant. So for example, if you have some object and you want to find out how far the object moves in a certain time. So let's say it moves with the speed v. How far distance will it move? S, depending on time. And then S is a function of the time. In this case, you write the function with the letter S. That's often you use the same letter that it will give out. For example, if you have a function written like this, then it's also common to write instead of writing an F here, you could write Y. So you can write Y of X. So what you get out, Y, you call the function the same letter as what you get out. So Y is a function. Y is a function of X. And here, the distance it travels, S, is the function of the time. So the formula could be, if you take the speed times the time. So this is a function that will give you the distance it travels when you plug in different times. So here time is the independent variable and distance is the dependent variable. Another example is, for example, the price of a taxi cab ride. So the price you have to pay if you go a distance of X kilometers, you have to pay a fixed price, for example $5 plus $2 per kilometer you travel. Then the price is a function of distance in this way. This is the function of the price function of X, the distance you travel. Then of course you could have also other variables. For example, you could have time or something. You pay here for every hour you travel, so you don't only pay for distance, but also for time. then instead you would have a function of two variables, x and t. But we will here limit ourselves to function with one variable. So we won't study those with two or more. It's not necessary to describe a function with a formula like we have done. For example, this function. Or we could write, of course, as f of x, 2x. But it's not necessary to give the function in terms of a formula. We could also describe it in another way. For example, we can describe it in Word, that y is equal to the double of what you plug in. So here we have described the function but in words instead of a formula. Or we could give it in terms of a table. For example, if you put x is what you plug in, and then y is what you get out. So if you plug in a 0, you should get out 0. If you plug in 1, you should get out 2. If you plug in 2, you should get out 4. Plug in 3, get out 6. Of course, you can't generalize from this and say, aha, it must be this function, because it could be some other function. But if you want to describe with the table, this function, you could describe it like this. Then it should actually contain infinitely many numbers here. But so if we say that we limit ourselves to integers, we can write like this. So we can describe a function in terms of a table also. We can also describe a function in terms of a picture. For example, if I have the x's here, so this is the x's I'm allowed to put in. And then the x's I can get out. Then I could describe the function as drawing arrows, meaning that here are all the x's, here's the domain, and here's the codomain, all the y's. So if I put in 0, I will get out 0. If I plug in 1, I will get out 2. Plug in 2, I will get out 4. And like this. So I could describe my function in terms of this picture also. A common way of representing your figures, your functions, is giving a graph or curve in a diagram. So a curve diagram. So you put your x's, or what you put into the function, you put on the horizontal axis, and on the vertical axis you put out what you will get from the function, y. So then I can describe my function in terms of some curve here. So if I draw a curve here, then this describes a function. Then of course I could have some numbers here so I know what I am reading off. So 1, 2, 3, and so on. And the same here. And of course I should do it more carefully so I can read it off more accurately. So for example, if I want to find out what will I get if I plug in 5, or let's take 3 instead. If I plug in 3 to the function, what will I get out? Then you should read the diagram in the following way. You should go from 3 up, straight up, until you hit the curve. And when you hit the curve, you should go to the left, to the vertical axis, and there you read off what you will get out. So if you plug in 3 in your function, you see that you will get out 2.5. So in this way you can read off the diagram. So this is how you interpret this kind of curve if you want to read off. So you can give a function in terms of a curve. So that is how you interpret or read off a curve. So once you have a curve, you can read off the function from the curve. But you can also do the opposite. So let's say that you have a function y f of x 2x plus 1. So let's say I want to draw the curve corresponding to this function. How do I do that? Okay, so let's draw a diagram. So again, I'll put my y there and x here. So now I need to draw some curve here representing this function. So how will I do that? I can start by doing a table. Then I need to put some values here of x belonging to my domain. Now I can choose some values here really freely from the domain. So let's just pick some at random, but let's pick 0, 1, 2, 3. And then maybe from these, maybe it's enough to figure out how the curve looks. And if that is not enough to figure out how the curve looks, we have to add more points here until we are convinced how it will look. So if I plug in 0, I will get out 2 times 0 plus 1, I will get out 1. If I plug in 1, 2 times 1 plus 1, that's 3. Plug in 2, I will get out 5 and 7. So now I have some points here I could plug in. So let's put them into my diagram here. Then I need to know what is on the axis here. Okay, then of course you should do it more carefully if you have a ruler and but I'm only sketching here. Okay, so let's plug in the points. Here we have 0, of course, and 0 there. And if I plug in 0, we should see that we should get out 1. So these pairs of numbers, they correspond to coordinates in this system, coordinate system here. So if you have a point in this coordinate system, you should have the coordinates 0, 1. Mean on the x-axis you should have 0, on the y-axis 1. So that corresponds to this point. So here is the point 0, 1. Okay, the next point 1, 3. Then 1 on the x-axis, 3 on the y-axis. So that's the point 1, 3. 2, 5. 2 on the x-axis, 5 on the y-axis. And 3, 7. So 3 here, we go up to 7. Okay, so now if I connect these points with a line, you see that this lies on a straight line. So if I draw not just these 4 points, but infinitely many points, if I continue to put in points here, all of these points together will make up this line. And that's called the graph of the function. So that's the graph of f of x. So that's the curve you get if you plug in all points in this diagram. So this is how you, if you start with the function, for example as a formula, then you can make the graph or the curve of the function in this way. You make a table and then put in the points into a diagram or coordinate system. So now I could read off. So instead of using this table, this formula, I could again read off here. For example, if I want to know that what is the function will give me out for 3/2, then I need to go up here. And then I can read off 4. Okay, so that's how you make a graph of a function given, for example, a formula. I could of course have started with some other description of a function, but we will mostly look at formulas. Okay, let us take some concepts of a function. So let's draw a function or a graph of a function. So if we have some function here, then we have different points on the curve here. Here we have a local maxima. So we have a local maxima because around this point here, around this point x here, the curve is at its highest. So we can't get any higher up than here, at least locally, if we stay in the vicinity of this point. So this is called a local maxima of the function. In the same way, this is called a local minima. Okay, so local maxima and local minima. Then we can also talk about global maxima. For example, if the curve ends here and starts here, then we can talk about this point, we can talk about as the global maxima. Because it's the highest point of the curve. Of course, a global maxima is also a local maxima, but a local maxima doesn't need to be a global maxima. And this point here is a global minima. Then the function also have a number of zeros. Here is a 0. That's the point on the curve that function is 0 for. So for this x here, the function is 0. If we read off on the y-axis, it's 0. So that we call a 0. This point we call a 0 of the function. So this is a 0 of the function. A function can have 0 zeros, or 1 or 2 or 3, infinitely many zeros. So a function doesn't need to have a 0, but you can have a 0 and can have many zeros. And it's often in mathematics interesting to find zeros. For example, we had another lecture, we have a person throwing up a ball into the air. And we wanted to find out when it hits the ground. And that corresponding to finding a 0 on the curve, or finding a solution to an equation. So it's often interesting to find zeros for a function. Then we can also talk about continuous and discontinuous functions. So let's just draw some arbitrary function here. If I can draw the graph of the function like this without lifting the pen from the paper, if I can draw this like this without any jumps, then this is a continuous function. But if I can't do that, for example, if I have a curve looking like this, and then suddenly I have to make a jump here, this is called a discontinuous function. Not all the curves correspond to functions. For example, if I draw a curve like this, this does not correspond to a function. And why is that? Yes, for the following reason. If I put in, for example, this x and try to read off what y I will get, you see that if I go up here, should I stop there, or should I read off here, or should I read off here? So what value should I read off? So this is ambiguous. In this case I get 3 different points, but even if I just only gotten 2 points, or 2 or more, it's ambiguous what to read off. So we can't have a function having a curve like this. So this does not correspond to a function. So not every curve corresponds to a function. It's not a graph of a function. So the curve must be strictly in one way, so to say. So it can't go back on itself. So it must go forward. But it can jump like this. It can be discontinuous. Because in this case, there's no problem of reading it off. So if I put here, I can read it off here. If I put in here, I can read it off here. But okay, I need to be a little bit careful, because if I try to read off here and see what it is, then I need to be careful to specify what I should do here. So sometimes if you draw a filled in point, that means that this point belongs to the curve. And if you draw a not filled in point, it means it does not belong to the curve. So in this case, if I want to read off exactly for this value where it jumps, then I shouldn't read off here, because this point doesn't belong to the curve. I should go up here. So in this case, it's okay. This corresponds to a function. But if I would have filled in this point, then it wouldn't be a function anymore. Because if I try to read off here now, where should I read off, here or here? It's ambiguous. Then of course I could say that, okay, let's exclude this from the function's domain, this point. Then the rest is a function. But you have to be careful exactly here so you can read off unambiguously. Otherwise it doesn't correspond to a function.